Video, we're going to examine how to graph rational functions. As we take a look at this first rational function, the first thing we should do is break up all the polynomials, both on the numerator and the denominator. So I'm going to go ahead and do that. We're going to start off with the numerator. This is the same thing as x minus 2 times x plus 2. And on the bottom, we have a trinomial. We can factor that out. We'll get x plus 4 and x minus 1. At this point, we look for all the important parts of our rational function, things like the x-intercept, the y-intercept, any vertical asymptotes, and any horizontal asymptotes. As we take a look at the numerator, we see that the x-intercepts will occur at 2 and negative 2, or we have the order pairs at 2, 0 and negative 2, 0. For the y-intercepts, that's when we set our x value equal to 0. So just imagine that we had zeros in all of our x's. And when we do that, we'll get negative 2 times 2. So we'll get negative 4 over 4 times negative 1. So another negative 4. So the y value will equal 1. So we're going to see that our y-intercept occurs at 0, 1. For the vertical asymptotes, we look at the denominator. We can see that the vertical asymptote will occur at negative 4 and also at 1. The horizontal asymptotes, as we take a look at the degrees of our, the leading terms of our numerator and denominator, we can see here that they both have the same degree, and therefore the horizontal asymptote will be the coefficients of both of them, which is going to be 1 over 1, or simply we'll have a horizontal asymptote at y equals 1. So we're going to go ahead and graph this now. Let's say that every unit will just be a unit of 1. So 1, 2, 3, 4, 5 as such. 2, 3, 4, 5. And negatives as well. And then we'll go ahead and also plot the values that we have found so far. So we have found values at 2, 0. I'll do this in a different color actually. Let's go with blue. So we have 2, 0 as an x-intercept. We have negative 2, 0. We have a y-intercept at 0, 1. And then we also have vertical asymptotes at negative 4. Okay, so we have a x equals negative 4 there. And we also have a vertical asymptote at x equals 1. X equals 1. And a horizontal asymptote at y equals 1. Now keep in mind, you'll notice that the y-intercept at 0, 1, it looks like it's intersecting the horizontal asymptote. And remember what we talked about is how, at least in the middle of the coordinate plane, right around the middle of your graph, it is okay for a function to pass through asymptotes, horizontal asymptotes. Horizontal asymptotes just show you end behavior. And so the last thing we can do is just do sign analysis and just see where our function is headed. For some of our graph, we actually don't need to really apply sign analysis if you can see what's going on the graph itself, because you see a x-intercept occurring at 2. We can already determine that this section of the graph, it will occur kind of like in that bottom right-hand corner. So we can go ahead and draw our graph. It's going closer and closer to the asymptote. It'll go to that value at 2, 0, and then come down and swing closer to the vertical asymptote at 1. So we'll have that part of the graph already. In terms of the other part, we have on the sign analysis chart, we can see that we have an x value at negative 4. So let's just go ahead and test a value, something like negative 5. So if we test negative 5, we're going to plug that into our rational function. So just imagine negative 5 is replaced for all your x values. So we'll have a negative value times a negative 5 plus 2. That'll give us a negative value. And then on the bottom, we'll have negative 5 plus 4. So that'll give us a negative value. And then a negative 5 minus 1. That'll also give us a negative value. So altogether, negative, 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 negative. Altogether, this area is going to be a big positive value. So because we can see that this section of the graph, these are technically in the negative territory, to get to the asymptote, you'll need to go through negative numbers. Sorry about that. So we know that we are not going to be in this quadrant here. We will instead be in this upper left-hand corner over here. So we're just wrapping our graph around. It's in the positive area, and we're just wrapping it towards those asymptotes. The last thing we need to do is figure out what's going on in the middle section. We also have another vertical asymptote here at 1. So in between negative 4 and 1, let's just figure out what's going on here. Well, we do see that there's an x-intercept at negative 2, 0. Let's just see what's happening as we test a value like negative 3. So doing the same thing, we'll plug negative 3 minus 2, so we'll get a negative, times negative 3 plus 2. That'll give us a negative, over a negative 3 plus 4. That'll give us a positive. And then negative 3 minus 1, that'll give us a negative. So negative times negative divided by negative, that's going to give us a negative. So at negative 3, we're going to get that to be negative. So to the left of that x-intercept, it's going down towards this vertical asymptote. It comes up, it hits this point right here, and right away we can actually determine that the graph is going to go up even more towards the vertical asymptote. It is going up because if it were to go down, then we should have also gotten another x-intercept, which we didn't. So we know that we actually don't have that graph going downwards to a negative infinity. Okay, so that's going to be our graph for example number 4. Example 5, let's do this one now. So as we take a look at the function, again, we'll just break things up. We see that the top, being a trinomial, that can factor out to x plus 2 and x plus 1. And the bottom will just be x. Okay, so as we take a look at this, the parts, let's go ahead and label x-intercepts, y-intercepts, vertical asymptotes, and horizontal asymptotes. So as we look at the x-intercept, that will tell us that the x value will be at negative 2 and also at negative 1, right? So we have the order pair negative 2, 0, negative 1, 0. The y-intercept is when the x value is 0, so just imagine, you actually can't get that, right? Because then you would have a 0 on the denominator, so there is no y-intercepts in this case. For the vertical asymptote, we can see again the denominator. That's when x is equal to 0. That'll be a vertical asymptote. And as we take a look at horizontal asymptotes, we can actually see here that the degree on the numerator is 1 degree more than the degree on the denominator. So actually what we're going to do is we're going to divide it out. X divided, or sorry, not the other way around. X squared plus 3x plus 2 is divided by x. Okay, so dividing out, we'll get x times x gives us x squared. And, I put that in the wrong spot, sorry. X times x gives us x squared. Bring down the 3x. We have that multiplied by 3 to give us 3x. And then we have a 2 here. So we have a remainder of 2 over x. Keep in mind, as x goes to infinity, this basically goes to 0. So we don't actually have a horizontal asymptote. Instead, we have an oblique asymptote, and that's occurring at the line y equals x plus 3. So if y is equal to x plus 3, let's just go ahead and start labeling our graph here. Again, let's make our coordinate plane. I'll make everything in terms of units of 1 again. Okay, and let's start plotting some things. We know that the oblique asymptote is y equals x plus 3, and that is a y-intercept of 3 and a slope of 1, so up 1 over 1, basically everything along this point here. We can go ahead and graph this as a dotted line. This is our oblique asymptote, just like that. Okay. And then we have a vertical asymptote at x equals 0, so that'll just be along the y-axis. Okay, there we go. Just like that. Okay, and then we also have x-intercepts. I'll do this in a different color so we can differentiate between the graph. Let's go with green. All right, so we have x-intercepts at negative 2, 0, at negative 1, 0. That's it, no y-intercepts. Oh, yeah, we don't have y-intercepts because we have a vertical asymptote there, right? All right, so let's go ahead and graph this. We'll need to do some sign analysis here. With sign analysis, I do see that we have values at negative 2, negative 1. And let's see what happens over here. Let's just go ahead and, as we test some values, we can test a value like 3, let's say. We have our vertical asymptote here at 0. So if I test a value like 3, just imagine here we got 3 plus 2, that's positive. 3 plus 1, that's positive. Over 3, everything's positive. So 3 is going to give us positive, positive, positive. So everything in this area, just a big positive. That shows us you can't have anything in this region because you would have values of x that would end up going negative as you go to that vertical asymptote. So we can then conclude that this section right here, we're going to start up here at the vertical asymptote, come down, and it's going to wrap towards your oblique asymptote like this. Okay, so you got this cool little, cool little angle right there. Okay, and then now we have another section to graph. We can see here that we have 2 points, -2 and -1. Let's imagine that we just plugged in a value like -1.5, negative 1.5. If we plug that in, -1.5 plus 2, that'll be positive. -1.5 plus 1, that'll be negative, and -1.5 on the bottom will be negative. So altogether, -1.5 will give us a positive value. And if that's the case, then that's showing us that right here, in between -2 and -1, you're getting a positive value like this. So it's kind of coming around like that. And then we can just double check our work, just make sure it's all working out. So obviously we're going to be going towards this oblique asymptote, but if you really want to make sure that this graph is going downwards, again, you can do sign analysis, right, and plug in a value like -0.5 in there. And, just -0.5 plus 2, that's positive, -0.5 plus 1, that's positive, and -0.5, that'll give you negative, right? So we can see that we should have this value coming down like this. So you can see that this graph, I just want to make sure you're aware of how this graph is drawn. This graph goes towards that oblique asymptote. It comes through the x-intercept, then immediately turns around, goes through -1, and then goes towards your vertical asymptote downwards, just like that. Okay, so that's what that graph looks like. All right, let's go on to the next page. Okay, so all right, so going on to example 6, let's take a look at what we have here. Again, we have a trinomial on the top. Let's see, can we factor that out? Yeah, we can. We'll get that to be 2x minus 1 times x minus 2 over, and then x squared minus 4, difference of squares, will give us x plus 2 and x minus 2. And one thing that you can notice here is whenever you have factors on top and bottom, that's what's going to give you a whole, and that whole is going to occur at x equals 2. Okay. Other things that we can find are the x-intercepts, y-intercepts, vertical asymptotes, and horizontal asymptotes. All right, so again, we'll start that process. Now notice that when we did simplify, all we have left on top is a 2x minus 1, meaning our x-intercept is going to be at 1/2. So we'll have 1/2 comma 0. The y-intercept is when x is equal to 0, so just imagine x is 0. We're going to get -1 over 2, so our y-intercept is going to be 0, -1/2. Did I do that right? No, I don't think I did that right. Yeah, I did. No, it's fine. 0, -1/2. Okay, so after that, we then can go ahead and find the vertical asymptotes, and the vertical asymptote just occurs at -2. And the horizontal asymptote, notice how they are the same degree. So we'll have a horizontal asymptote of the coefficients of the leading term, so that's going to be 2 over 1. So we have y equals 2. All right, so let's go ahead and graph this. So again, based on those numbers, should I change it up? Yeah, why don't we change it up? I'm going to make every 2 units a length of 1. So 1, 2, 3, 4, 5. I hope I don't regret this. -1, -2, -3, -4, -5. 1, 2, 3, 4, 5. Okay. So as we graph, let's see what we have here. X-intercepts are at 1/2, 0. So let me do this in a different color. Let's go with green. 1/2, 0. There's 1 point. Y-intercept is at 0, -1/2. Here's another point. What else do we have? A vertical asymptote at x equals -2, right here. That's x equals -2. And a horizontal asymptote at y equals 2. Just like that. Okay. Let's see what we're going to do now. Oh, yeah. Okay, so we see that there's a hole here. So the hole is at x equals 2. Now, the common misconception, a lot of students make a mistake on is, oh, since we have a hole at 2, that's going to be a hole at 2, 0. That is not necessarily true. What we need to actually do is, technically speaking, when you see this graph come through those points and go towards the asymptotes, to figure out what's happening at 2, what we really want to do is plug the hole, the x equals 2, into your actual function and see if it were to go through 2, then what would the y value be? So if we actually plug in 2, we're going to plug in r of 2. Let's see what we get. We actually get 2 times 2 minus 1 over 2 plus 2. And that'll give us a value of 4 minus 1, so 3 over 4. So technically speaking, the point at this function should have the point 2 comma 3/4. Okay, so at this point 2, it's not the x-intercept. It is not 2, 0. Instead, we are going to 2 3/4, and because it's a hole, you have a point of discontinuity there. And that just shows you how that graph should be angling towards that horizontal asymptote. And so it's coming through just like that. And there we go. We have our picture of the graph, right? You can see here that the curve is going through our y-intercepts, our x-intercepts, and then eventually it's going to go through our hole just like that. But don't make that common error of saying that I'm going to place the 2 at the x-intercept because, we see that x minus 2 there. That's something that, you might tend to want to do, but just realize that the hole is actually not on the x-intercept. Okay. After that, it's really just pretty simple to do. Now you can just do your sign analysis and say, well, if we're at -2, then what's to the left of that? Let's just plug in a value like -4. All right, so if we plug in -4, -4 minus 2, -8 minus 1, that'll give us a negative value. And then divide that by, what do we have? -4 plus 2, that's a negative value. So negative over negative, that gives us a positive value. And therefore, our other part of the rational function will be only strictly positives. And so we are going to come in this, what do we call this? Like the second quadrant almost, right? Right over here, just like that. Okay, and that'll conclude the graph for example 6. All right, example 7. There are quite a few rational functions, so just bear with me here as we go through this video here. So if we have this polynomial function already factored, that kind of helps us out. We can already identify our important parts: x-intercepts, y-intercepts, vertical asymptote, and horizontal asymptote. Okay, so the x-intercepts occur at, let's just write it down as ordered pairs, 1, 0, and also the x plus 2, that'll give us -2, 0. The y-intercepts occur when x is equal to 0, so just imagine that x is 0. We'll get -1 times 2 squared, so 4 over, what did we say? X is 0. Oh, again, we have no y-intercepts, right? We can see here that the bottom will have a 0 on the bottom. All right, so the vertical asymptotes, that's going to occur at x equals 0 and also at x equals 4. Okay, so there we go. The horizontal asymptotes, what do we have here? This is a second degree multiplied by a first degree, that is x cubed, over a second degree times a first degree, that is also x cubed. So you have an x cubed times x cubed. Imagine if you were to multiply it all out, what would be the leading terms? We have x times x is x squared times x. You truly do get a 1x cubed. And then x times x gives you x squared times an x. You truly do get a 1x cubed again. So based on that, we can see that the horizontal asymptotes are going to give us y equals coefficient of the leading term on the numerator as well as coefficient on the leading term on the denominator. So we get a horizontal asymptote at y equals 1. Let's graph it. I'm going to go back to units of 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just personal preference, doesn't really matter. I don't want to regret my decision and have to erase everything because we actually have to zoom out or anything like that. Alright, so here we have x-intercepts at 1, 0. Let's just do this in a different color. 1, 0, negative 2, 0. Horizontal asymptote is at y equals 1. And vertical asymptote is at 0. This video is getting kind of long. I think I'm going to stop here after we finish this problem. X equals 4. And then I'll create another video for the second part of our notes. Okay, so there we go. Let's see what we have here. I don't have a lot to go off of. I'm going to do some sign analysis here. Now, strictly speaking, I kind of can safely assume that to the right of 4, I should get all positive values because I don't see any x-intercepts here. So my graph should technically just kind of go like this. And I could just double check my work to be safe, plug in 6, 6, positive, 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 positive. Yeah, that's going to be all positives. Okay, so I don't have space to write it down here. Positive times positive over positive times positive. All right, let's see what's going on here. Okay, so we have an x-intercept of 1. We have a vertical asymptote at 0. And so let's see what's going on. I don't know how this graph is moving. So we should test a value like half, let's say. If I test a value like half minus 1, that'll give us negative, times half plus 2 squared, that'll give us positive. Half is positive, and half minus 4 squared is positive. So altogether, the section of half is going to give me negative. That's showing me that my graph is going to come down towards the negative infinity, going towards that asymptote, just like that. And also, because I have no other x-intercepts, my graph can't come back down like this. That's not possible. I have no x-intercepts here. So therefore, I know the only solution I can do is just kind of come up and go to positive infinity as we work towards the other vertical asymptote, just like that. Okay, so there we have that portion of the graph. And then lastly, again, we have this negative 2. We got to figure out what's going on. Again, with sign analysis, I'm just going to space it out so we can see what's going on. Here, here's negative 2, okay, which was that part. To the left of negative 2, let's plug in a value like negative 1. To the right of negative 2, let's plug in a value like negative 4. Okay, so with negative 1 in place, again, I have no room down here. Or actually, let me see what I can do here. So when I have negative 1 in place, negative 1 minus 1, that'll give us negative. Negative 1 plus 2 squared is positive, over negative 1, that's negative, and negative 1 minus 4 squared is positive. Altogether, that's giving me a positive area. So at negative 1, my graph is actually working its way up towards infinity. And remember, I can cross the horizontal asymptote. So we're going to infinity. Sorry, my drawing is not very good. I'm drawing with a stylus, so it's not very accurate. Okay, so we're going to infinity. And then let's see what's going on now. You just be safe here. Plug in a value like negative 4 and see what's going on. Negative 4 minus 1 is negative. Negative 4 plus 2 squared, that's going to give us positive. Negative 4 on the bottom is negative. And negative 4 minus 4 squared is positive. So, oh, look at that. Again, we're going to get a positive number at negative 4. Oh, that is interesting. So we can see here that this graph is not coming down like this. Keep in mind, especially when we see a horizontal asymptote, that's showing us end behavior. So the graph should actually be going towards that asymptote. So as we draw this graph, you can see it's coming up from here, from positive infinity, coming down, and I probably didn't draw that right. Let me draw it again. I'll show you the path it takes. It goes down. It's almost like a race car drifting, and it's going, it didn't make the turn, and so it's going to rebound off that negative 2 and come back around. Imagine a car drifting, and it gets closer towards that asymptote. Remember, you're getting closer and closer as the horizontal asymptote shows you end behavior, just like that. Okay. All right, so there we go. That is our final graph for the graph for problem 7. I'll stop here and then we'll start another video for part 2.